This is Lab 27, the iodine clock reaction in honors chemistry. This lab is designed to show you what happens when you mix two different solutions containing two different reactants together that produce a very distinctive and maybe surprising at first chemical reaction. You're going to have solution A and solution B. They will look distinctly different from one another. You will be able to tell them apart. And the important part overall in this lab is to keep them separate until you mean to mix them together. As soon as you mix them together, you will need to start a stopwatch in order to time the length of time that it takes for them to react. How will you know when they react? You will know. It will be very clear, very obvious to you that the reaction is complete. I will leave you to discover what that reaction is when you get into lab. It's not dangerous, don't worry. So this lab takes into account two different factors on the effect of reaction rate. One is concentration, so this will be true in part A. You will be investigating concentration. In part B, you will be looking at the effect temperature plays on reaction rate. In part A, it is a good idea to have each lab partner in charge of one of the solutions. Make lab partner 1 in charge of A, make lab partner 2 in charge of solution B, so that you each keep them straight and separate. You're going to be measuring, starting out with 10 milliliters of each, A and B. You will have two different graduated cylinders, two of them, one for A and one for B. Do not mix them up because you will have the reaction occur when you're not ready for it if you do. If that should happen and you mix your graduated cylinders up, just let me know and I will get you new ones or instruct you what to do to fix it. So together, you and your partner are going to work to mix the two solutions together into an Erlenmeyer flask. The Erlenmeyer flasks will be set out for you. Upon mixing them together, you're going to swirl and you're going to time using a timer. I will have stopwatches out and available for you. I do not recommend using your phone in case you spill the solutions. It may damage your phone. Once the reaction has occurred, you will record your data. You will rinse the flask between trials. All you need to do is to rinse with distilled water, which you will have available to you in your squeeze bottles at your lab station. You do not need to wash the flasks any more than that. Continue to do that, measure A, measure B, according to the recipe here that you have in data table part A. So solution B, you notice, remains consistent throughout. It stays at 10 milliliters. Solution A will vary. In addition to solution A, you must add water. So these two will go together to measure out solution A for a combined total always of 10 milliliters of solution A. That way, you have not 10 milliliters of solution A, but 10 milliliters of this combined water and solution A. In other words, you're diluting solution A as you go through a series of trials. So that's part A. In part B, you're going to be varying the temperature for a series of trials, in which case you need to have a hot water bath. So the hot water bath you can certainly start earlier on. In fact, let's see, up here under the materials it says have a hot water bath. You can start this immediately upon beginning the lab. You can do it right at the beginning, right when you're getting going with part A. Just turn the hot water bath on, turn it on to about 50 degrees Celsius. That's what you want to get it up to. Turn your hot plate on halfway, and then it'll be ready for you when you get to part B. So at part B, you're going to measure out 10 milliliters of A and B, just like you did in the first half of the lab, but you're going to put them into the warm water bath and let them come to a temperature that you want them to be at. For this one, you want a temperature that's somewhere between 30 and 50 degrees Celsius. It doesn't matter exactly what the temperature is. It could be 33, it could be 42, it doesn't matter as long as you record the exact temperature in this data table. For the other two test tubes 1 and 2, you're going to obtain a temperature somewhere between 0 and 10, and somewhere between 10 and 20 degrees Celsius. So their first temperature will be in the single digits, the second temperature will be in the teens, the third temperature will be room temperature. But notice trial 1 from part A is the very data that you're looking for in part B. Room temperature for trial 1, part A, can just be transposed from here down to here. Same as trial 1, part A. If you want to, you can do it again if you have time during the lab, but that will save you a step. Once you have completed those 3 additional trials for part B, then you can dispose of all the solution that's left over. It can all get washed down the drain with plenty of water. Rinse out your graduated cylinders and your Erlenmeyer flask, and your lab is complete. You may move on to creating 2 graphs to illustrate your data points. Good luck!